The first lesson that we'll do together in Algebra 2 this year is Unit 1, Lesson 1, and we'll talk about domain and interval notation. Domain shouldn't be completely new, but many students get confused about domain and range, and so I'm going to introduce it as if you have not seen it before. Interval notation is new, I believe, in Algebra 2. And this is how I'll number our units. This is 1, 1, so it's Unit 1, Lesson 1 notes. Our essential questions are, first, how do I identify a function? And we'll use vertical line test for that. There's another rule for that. I'll explain in just a moment. And then also, what is domain? So how do you define domain? What does it mean? And how do you use interval notation to describe it? Okay, so first, what's a function? Well, for every input, which is x, there should only be one output. Output is y. For every input, x, there is only one output, y. If there's more than one y for an x value, so if your x's repeat, basically, you won't have a function. So I have a couple examples. Well, I have a non-example here, which would be if I have a list of points, how about 1, 2, 4, 7, and 1, 5. Okay, this is a non-example because I have 1 matched up with 2 as an output and 4, 7, and then I have 1 again matched up with a different output, and that breaks my rule. So because there are 2 y values that share the same x, it's not a function. Here's an example though. And for this example, I'm going to use a map 0, 3, 6. These are inputs, x, and they match up with these outputs, -1, 0, in this way. 0 matches with -1, 3 matches with 0, 6 matches with -1. You might think, wait a minute, both of these things went to -1. Let's write the list of points that this represents. I have 0, 1, and I have 3, 0, and I have 6, 1. So I did use the same output more than one time, but I did not use any inputs more than one time. So this is a function. Now, what is domain? Well, domain is all the x values in a relation if you have a graph or a list of points, or a graph, that may or may not be a function, I can still, if I list all of the x values, I can show the domain, even if it's not a function. This would be considered the independent variables. And the way you can remember that x is independent and y is dependent is that when you have an equation, you usually put y equals something with x plus whatever. The y value depends on whatever you choose for x. So x is independent and y depends on that x that you choose. This is also your input. X is your input. Okay, now I have my last big question. What is interval notation? You guys haven't seen it before. It's pretty easy to use. This is what we'll be using this year. Interval notation represents, oops, love erasable pens, represents the interval graphed or described. Okay. It's always least to greatest. And really, that's a really big deal. It has to be least to greatest. So this is very important. Your interval can be open. Let's show like a number line here so I can explain. Okay, I have a number line and I'll put me some, I don't have to label them even necessarily, but it can be open, like an open circle. It can be closed. Okay. And I'm graphing. Here's my whatever I'm graphing. Okay. This isn't a two-dimensional graph like what I have below, and that's okay because I'm only describing the x value anyway. I don't need a y to do the domain. Here I have an open circle. So I call that an open interval. Okay, then I would use parentheses whenever it's open. And it also can be closed. Closed interval, closed circle, and I would use brackets. Sometimes I'll say square brackets just to like emphasize. Okay, so we will use interval notation to describe the span from least to greatest that describes our x values, the domain. Here I have some graphs. I have 4. Find the domain of these graphs, write it in interval notation. Use the vertical line test to determine if each is a function. I can either use a vertical line test or know that, or cannot use x value more than once. So whichever way you remember that, vertical line test or x's can't be repeated. Okay, so here I have domain for this circle. And I want to know what is the least x smallest x is negative 1, 2, 3, 4, 5, 6, 7, 8, 9. And I just put a comma. I'm going to make it like a list, least to greatest. And then my biggest, largest x. And I'm not going to worry about what's going on with the y. I'm only talking about domain today. This is at 1, 2, 3, 4, 5-ish. I eyeball it. Okay, I have a closed circle. Compare that to, this would be an open circle if it was a dashed line. Okay, so I'm going to put square brackets on here because my x values are from -9 to 5, including -9 and including 5. So closed. Is this a function? Well, you can pick any 2 points on here. This is negative 1, 2, 3, 4. -4. 1, 2, 3, 4, 5, 6, 7, 8. Okay, but I also have another point where x is -4, and that's at -4, -1, 2, 3, 4, 5-ish. So because I have x's that are used for more than one y value, or because if I draw a vertical line through my graph, it touches my graph more than one place, it's not a function. So either way you want to do that. Okay, next. This is an absolute value graph. We'll do that this semester later. My domain is from here, which there's an arrow pointing that way. Since this doesn't stop at a point like these, where it stops, that's considered an open interval because it continues. If it doesn't have a boundary, a true number boundary, then it's open. Okay. When I write my smallest x value, there isn't one. There's no smallest. It continues forever, negative. So I call that negative infinity. Continues in a negative direction forever. Okay, since I'll never get to negative infinity, that's an open interval. And I also don't have a largest, no largest. It just continues forever. That's positive infinity. Is this a function? Yes. I try vertical line test. It doesn't matter where I draw my vertical line. I don't use x values more than one time. So yes, that's a function. I'd like for you guys to try these two. Go ahead and pause the video and turn it back on when you're finished, and I'll show you. You can check and make sure that that we agree on the domain and whether or not it's a function. So here I've filled in domain and whether or not it's a function for each of these. And I realize these endpoints are not exactly on a grid. So you just kind of eyeball it. I'm going to call this -8. Whenever you have an arrow that is open. So I'm going to make a note here since I have filled up the space here, just to remind myself. If an end point, put that in quotes, it's not really an end if it has an arrow, is an arrow Goodness me. Okay. 0. Then it's open. Okay. And we do differentiate between negative infinity and positive infinity, least to greatest. Okay. What did I do? I counted these blocks. This is an arrow. This is infinity. There we go. All right, kids. You do have some practice, and you can check on Canvas for the answers and check as you go, or come and ask me. I'll have it at my desk. Work carefully. Good luck.